Okay, guys, we are going to go ahead and get started by looking at the first type of naming, which will be naming ionic compounds. I always start with these because they are definitely the most simple in looking at what we just did with bonding. So, key thing to remember about an ionic compound is that we're going to use this system of naming whenever we see a metal plus a nonmetal. So in looking at some of the examples, all these examples are from the PowerPoint, so I realize you can see the answers, but I just kind of want to talk you through how we came up with those answers. When we see aluminum, we know that aluminum is a metal, and we know that oxygen is a nonmetal. And again, these are very easy to name because all you have to do is state the name of the metal, which in this case would be aluminum. And then on the nonmetal, which in this situation is oxygen, you change the ending to IDE, so it would just become oxide, IDE. Down here, we see that the metal is zinc, and iodine is our nonmetal. So again, we're going to name the metal, and then on that nonmetal, we're just going to name it iodide. Again, change the INE to IDE. Next one, ionic. It's a metal and a nonmetal. So once again, we're going to name our metal. If you look that one up, if you don't remember it, it is magnesium fluoride. We don't have to say or do anything with this subscript of 2 because it's ionic. We know that there's 2 fluorines to cancel out that plus 2 on the magnesium. And then the last one that we'll look at on this side is potassium, which we know is an alkali earth metal. So we've got potassium and oxygen. We're going to name the metal, which would be potassium, and then simply add IDE to that nonmetal, so potassium oxide. Okay, so usually for students, it's not difficult to be given the formula and then come up with a name. The part that you kind of have to put all this together on is when we look at just the name, and then you're asked to give the formula. And I'm actually going to turn this light off because there's a little bit of a glare there. Okay, so aluminum fluoride. If I were to say draw the chemical for aluminum fluoride, let's think about what you already know. You know that aluminum is represented with Al, and you know that the typical charge on aluminum is +3. You know that fluoride is the exact same thing as fluorine, so we've got fluorine who has a -1 charge. And now it's just back to what we were just doing with ionic bonding. We're going to look to see how do we get those charges to equal 0. How many fluorines do you need to cancel out that +3? You need 3. And so we're going to have a subscript of 3 on our fluorine, and that would be our chemical formula. If I asked you to write the chemical formula for barium sulfide, again, we know that barium is a metal, sulfide is a nonmetal. We know that that means it's ionic, so let's take a look at the charges. The barium is a +2, sulfide is a -2. So in this situation, the +2 and the -2 cancel out, and what you're left with is 1 atom of each. So just Ba and then S for the sulfide. And the last one, there's that metal, magnesium, and chlorine, the nonmetal. I mean, guys, this side over here is exactly what we've been doing with our chemical bonding. So we're going to look at that magnesium and see that it has a charge of +2. And then we're going to look at that chlorine and see that it has a charge of -1. I realize some of you are crisscrossing your charges, but again, I'd like for you to be thinking of this in terms of trying to get those charges to cancel out. How can we get the +2 to go away? We need this to become a -2. The only way to get a -2 there is to add another chlorine, and so we would end up with MgCl2 in order to get both those chlorines to cancel out. This is definitely by far the easiest type of naming, but you still have to understand when to use it, which is why identifying that compound, saying, hey, this has a metal and a non-metal, so this is the style of naming that I'm going to use. And that is it for binary ionic compounds.